but if you ask most people, what was your nitrogen use efficiency last year? Well, if they got an average on their farm of 240 bushel yields, you can know it was pretty blame good, because they just divide the yield by the nitrogen, and they say we only needed 0.8 of a pound of. The real problem with that is they're crediting the nitrogen that came from the soil. I think we would agree that the nitrogen use efficiency of fertilizer nitrogen is not nearly as high as we like to think it is.
Welcome to the Crop Science Podcast Show, brought to you by Wisenetics. I am Brian Arnell, and I'm coming to you from the campus of Oklahoma State University. Today we have on Dr. Emerson Nafziger. He is Professor Emeritus of Crop Scientists at the University of Illinois at Urbana-Champaign. Dr. Nafziger spent 36 years as a professor and extension specialist in crop production at the University of Illinois. He was one of the originators of the maximum return to nitrogen MRTN approach to nitrogen rate setting, which uses current nitrogen response data to produce guideline nitrogen rates that incorporate current prices of corn and nitrogen fertilizer. And the calculator is free online at cornratecalc.org. Dr. Nafziger, I was quite excited when I saw that they lined you up as a guest for me today. You've been around my entire career. You've seen me go from a grad student on up. And so thank you for taking the time to join us today.
Well, glad to be here, Brian.
So, Dr. Nafziger, can you spend just a little bit of time about talking about your process of academia? How did you end up, really being one of the innovators of nitrogen management at Illinois? Where did you get into even nitrogen, and how did you end up?
It didn't start out this way. This was not part of the plan. I was hired. My academic career went from Ohio State to Purdue to the University of Illinois. And when I finished here, I was interested in an academic position of some sort, but I wasn't terribly fussy about what route that took. And they happened to have a crop extension position open here, grain crops, corn primarily. Corn's our big grain crop. We have a little bit of wheat in Illinois, but corn and soybeans dominate the landscape. And so I started as the basically corn and wheat extension specialist. And we were looking at agronomic things and the usual things with management. And hybrids were changing rapidly. And one of the things that I was doing as part of that back 25, 30 years ago, maybe a little farther than that, was nitrogen rate work. And I started that with things like, do different populations of corn need different nitrogen rates and vice versa? And some of those things related to trying to manage better. And one thing I started to notice in the 90s was that our guidelines or our N-rate recommendations for corn were pretty much similar across states at that point. They were generally based on expected yield. And this sounds rational. I mean, if you expect 200 bushel yield, you use more than if you expect 150 bushel yield. Well, we found two things. One, especially when we're following corn after soybean, which we do with almost all of our corn today in Illinois, 90+% of it certainly. And we had that corn bulge back in the 20 years ago with ethanol and so on. So we had more corn after corn. But corn after corn was the one that was the first thing that people looked at, because after the middle of last century, we were really trying to get away from as we went away from the general dairy rotations, as we called them, we had to have a way to get nitrogen on corn, and we couldn't plow down red clover and use manure to the extent that we did before. And so that's when fertilizer, of course, after World War II is when it really started with anhydrous ammonia. And we first used that form, I think, back in the late 50s. And and it was cheap. And so the recommendations back then were just use plenty. And we got a little more rational, I guess, in the 70s. And people said, well, take the yield you expect and multiply it times some factor. And in Illinois, we said 1.2 is the most you should do. That just meant 1.2 pounds of nitrogen per bushel of yield you expect. Well, if you ask a farmer what yield he expects, different farmers would have yields. They expect yields higher than they've ever gotten before. And it's got a certain looseness to it. But the idea took hold with people that if I'm going to get higher yields, as the newer hybrids were allowing us to do, we just have to put more nitrogen on. We found that, in matter of fact, that didn't seem to hold very well. And my explanation, which is the only one I know of that makes sense, is that newer hybrids are better able to gather up nitrogen. They have more competent root systems. They can get the nitrogen. The other thing that it ignored generally, and I think this is the one that's probably had us in the most trouble, is that we pretend that the soil is not providing any nitrogen. So if we don't put fertilizer on, that crop's going to be just without any nitrogen. And so that was the two things that I noticed. Back in the 60s, I remember we had an anhydrous applicator. I grew up in Ohio, and I said the thing was rusted in place at about 180 pounds of nitrogen, and in a good year, we were getting 110 bushel yield. So that was more than you would have expected, and we were hauling manure too, because we had a feedlot. So in any case, long story short, I started to question in the late 90s, what's wrong with our nitrogen recommendations. The other part of that equation was in southern Illinois, which is quite different soils-wise, much lower organic matter. Back then, less productivity. Hybrids have helped fix that to some extent, but more drought-prone, excess water sometimes, not very well tile drained because tile don't work as well there. We found that the yield-based recommendation was actually too low there. They needed more, and farmers knew this. If we said, well, some people had a yield expectation in the 90s of 120, 130 bushel yields, and we also had an adjustment. If soybeans was the crop before corn, then you'd take 40 pounds off of that rate. So they were down to using 100 pounds if they had followed the recommendation. And they knew from experience that that wasn't enough. So we were too high with our recommendations in the more productive prairie soils, and we were too low in these lower organic matter soils. And so in the early 2000s, a group of us were meeting, and I had enough data by then that I was thinking, how in the world can we use the data that we've generated up to this point to sort of predict? Nothing is going to predict very precisely. I mean, let's be clear. As you well know, Brian, this guessing a nitrogen rate for a field for a given year is simply a guess. It is. And it can change on a dime. I mean, we all recognize that your best nitrogen rate for this field could be anywhere between 100 and 230 pounds per acre, and you honestly have little idea going into the season which end that's going to be on. And none of the attempts that have been made so far have actually worked all that well to model it and get all fancy with tools and sensing and so on. So that's why I came up with that idea in the group there, and it wouldn't have gone anywhere except there were people there that could help put it into place. And Dr. John Sawyer at Iowa State, who was a friend and colleague from the time he was here at Illinois, he was instrumental in taking it. And I said right away, let's turn these into an economic response, because that's where farmers live. When corn is cheap and nitrogen's expensive, you cannot continue to pour on whatever you think is enough. And we've had nitrogen up to $1 a pound. And you have to think about $2, 200 pounds when it's $1 a pound. And so that's how this all came about. And the MRTN tool, the website that you mentioned, simply takes a bunch of data. We have in Illinois a database with over 500 trials in it currently. And we're in the process of tossing some of the older data, because the older data showed, good yields, but not the kind of yields we're getting today. And not that the nitrogen rate was necessarily connected. I could show you a nitrogen rate response of any kind you'd like.
All of them.
All of them. You can have one example I like to talk about. We had a trial in Western Illinois, one of our most productive sites, and the yield without nitrogen fertilizer was about 250 bushels per acre. And people think, what? How is that even possible? Well, these soils that, accumulated over some thousands of years, all of the nitrogen, all of the organic matter they have, that organic matter is 5% nitrogen. We've got literally tons of nitrogen in every acre in these prairie soils. And only we think, rule of thumb is just about 2% of that becomes available, but 2% of that sometimes is 150 to 200 pounds of nitrogen.
Even in our high plains where we don't have that much organic matter, but they've been doing, we're used to be like Western Nebraska, Western Oklahoma, where all it takes is one good rooting year and we don't need much. If we can get those roots down to 4 foot deep, there's because we don't leach much in that soil, right? So you hit this clay layer at 4 or 5 foot deep, and if you get the roots down there, there's just this piggy bank of nitrogen. But if we got a year that it doesn't root well, 1 year we need 20 to 40 pounds to get to 300 bushel, and the next year we need 270 pounds to get to 300 bushel because of who knows.
And that trial I talked about, it still needed nitrogen, but it yielded, if we put 120 pounds of nitrogen on, that's about all it needed in that trial. It yielded 310. So then this is just showing what these hybrids can do. And it also shows you the elusive nature of nitrogen. So the nitrogen, the way I like to put it is, the nitrogen that comes from the breakdown of soil organic matter, the mineralization we call it, becoming available to the plant. It's the nitrogen. It's the first nitrogen the plant sees, and you've got roots that have gone out into that top foot or so of the soil. We don't pretend that ours are going to get 4 feet deep here, but they really don't need to with that soil organic matter providing so much there. And I do think our rooting, one of the big advantages, we've had dry June weather the last 3 years, and we've had good yields. And I think there's a connection between those.
I would agree completely.
We have a big problem if it's sopping wet in June, especially. Those roots have to be there. They have to be functioning. They don't have to be deep, but they have to be very well connected in the soil. And our hybrids today can do that. They have a lot of ability to do that.
I see for us, and it's not even it's even earlier for us. I really don't want us to have a lot of rain that first couple weeks. Like when it's wet after that seed gets up, we have so much more likelihood of green snap and things going sideways. But if we can just start with good soil moisture and have I don't want drought, but a relatively dry start, it seems like the plants have so much more capability to handle later season. I can only relate that to roots. To me, that is got to be heavily root.
It is, and there's two problems. The biggest problem for us with wet soils early in the season is that the roots don't work very well. And I've said this, for a long time. I said roots that are standing in water, an extra dose of they aren't turning yellow because they don't have nitrogen. They're turning yellow because they don't have oxygen. And I said, when oxygen is the problem, nitrogen is not the answer.
Mm-hmm.
And that's literally true. And we've had those dry years, those dry Junes are very helpful. I don't even mind seeing a little bit of drought stress, but as long as it gets relieved, let's be clear. We had 2012 and it never got relieved in time. But some of our best years, the hybrids are remarkably, they've been, I said, when you breed hybrids relentlessly for high yield, you get a lot of other things that come along as a way of explanation. And one of them is they can withstand, they aren't subject to this silking delay and all of this kind of thing. We often see silks out before pollen shed begins today. And that's just simply because of breeding.
It's interesting to work in a region that has cotton and corn for me, because the cotton has such a different mindset, right? The cotton growers really want deficit moisture. They want deficit nutrients early to manipulate plant structure, manipulate roots. They don't want a lot of water because they want those roots to explore. They don't want a lot of nitrogen because they don't want to be very vegetative. I'm finding there are some aspects of that cotton management, kind of more so the water. How do we manage water and irrigated system that relays now very well to some of our new corn hybrids? Is that I almost want to treat them. I don't want to go to the extreme of cotton, but I want to treat them a little bit like cotton, where I don't want heavy stress, but I want the plant to work a little bit early. I want them to explore. I want the plant to need a reason to explore the soil volume more than just being lazy in the top foot.
Right, and I fully concur with that. That's something that's more beneficial. I said that the good we get from dry is always better than the harm, if it's relatively early in the season. In 22, 23, 24, all of those had dryness in June that was relieved at some point. 22, it was late enough that I thought we would have a real problem. And we set a new yield record that year, 214 bushels per acre for the whole state of Illinois. We beat that in 2024 at 217. So, these are, over my career, our yields have essentially doubled in corn, and they've come fairly close to doing that in soybeans as well. And so that's something. How many of us, we had 200 bushel corn clubs back in the 80s and 90s, right? And people thought, man, well, you really got something put together there. I do credit a lot of it with breeding. Management we have to keep management concurrent. We have to watch pest control and weed control and this sorts of things. But genetics are, and the genetic changes have not told us, oh, you need to, have way more plants than you used to have and all of this kind of thing. If we're in the mid 30s with a population, we're fine in almost every case. The high yields we get are not dependent on high densities of plants. And so the upshot of all of this is that although we like to talk about improved nitrogen use efficiency, it's on everybody's mind. But if you ask most people, what was your nitrogen use efficiency last year? Well, if they got an average on their farm of 240 bushel yields, you can know it was pretty blame good, because they just divide the yield by the nitrogen, and they say we only needed 0.8 of a pound of. The real problem with that is they're crediting the nitrogen that came from the soil. I think we would agree that the nitrogen use efficiency of fertilizer nitrogen is not nearly as high as we like to think it is. And as that example, I mentioned the yield we had a 250 and then it went up about 60 bushel, but it took about 120 pounds of nitrogen. That's 2 pounds of nitrogen per bushel of added yield over what the soil was already giving us. On average, across all of our hundreds of trials in Illinois, the soil has provided, and we know this because we have a zero there. So with whatever I take the yield at zero, and multiply it times 1 pound per bushel, because that's about how much it takes up. It doesn't take off that much when you harvest it, but it takes up roughly that much. And so on average, about half of our yield is from nitrogen the soil provides, and about half is from fertilizer. And it's all over the place. I mean, we can have fairly low yields and need a lot of nitrogen because uptake wasn't very good. And we can, occasionally, not a lot of times, but occasionally, too much nitrogen can lower yields. With today's hybrids, that's a rarity. It does happen. More likely, we just get this leveling off at some nitrogen rate. And for us, in our revision we just did, our MRTN, that maximum return to nitrogen, we call it a guideline because, people take a nitrogen recommend. Everybody wants a number. Just give me a number. That was the beauty of I expect 200 bushels, so I'm going to use 240 pounds of nitrogen. And I'll 40 away if soybeans were the previous crop, and so that's 200 pounds of nitrogen. Well, if they're at 260 bushel yield levels, and some realistically have in their better fields averaged probably 240 to 250 over the last 3 or 4 years. If they're at that level, then they're back up in that 230, 40, 50 bushel range, or nitrogen rate range. And it's pretty, there's not a zero chance that the crop will need that much, but it's pretty low. And our biggest concern is, and some people still have this mentality, if that they credit their nitrogen rate, if they're using a high rate, they credit that as the reason they're getting high yields. And no matter how many trials we show them, I wish everybody would drop their rate for a strip or two in the field from whatever they're using to 30 or 40 pounds less than that and see if it really makes a difference or not. I think a lot of people would be fairly surprised.
I've gotten, so as an extension tool, I get people, and I've convinced a couple, and they do this more now because, especially when the fertilizer was high, I was able to convince them they've learned some. So I have them go out in a cornfield and just for a second turn off the applicator, just for 8 rows by 20 foot, just turn it off. And I said, just walk out there a couple times a year and know that if you see that and it's knee-high corn and you see that, then all the nitrogen you're putting on is going to be needed by the crop. But if you can't find that zero at enthesis, you need to step back a little bit and see if you really needed 270 pounds of nitrogen.
That's I've suggested that, knowing that nobody's going to do it. I think the retailers that make application maps just build it in, and it's actually I think we do get some years that when our zeros show deficiency pretty early, those are the ones that tend to have the biggest response to nitrogen. And I think it's a really, really valuable thing with all of the sensing, and I know a lot of that. I said, if we're ever going to learn to make use of this sense, I mean, one of my favorite pictures, I had a trial, we had a 0 and 200 next to each other. About the middle of June, I took a picture. The corn was nearly waist high, and you couldn't tell the difference between them. If it's dry early on in the amount of nitrogen they're getting from the soil can be tremendous. And so, but there was 100 bushel difference in yield at the end of the season. So it showed up after that. So it's still, but we have learned that trying to react to efficiency is not a very sound way to manage nitrogen. Once we see deficiency develop, especially if we're in a dry period and you're going to go out there and say, why drop some nitrogen? It can sit there for 2 weeks before the plant ever sees any of it. And it can be definitely too late by that.
Yeah, that's the fun thing about these irrigated fields with these guys. And I just tell them do, napkin math. If they're seeing the deficiency at R6, we have a pretty good idea of the uptake curve and what the crop's going to need beyond that point. They know what they put down pre-plant. And you can do some some quick math and say, okay, I'm going to put on 60 pounds with fertigation, or I'm going to put on 30 pounds with fertigation. But if you are at R1 and you haven't seen it yet, then you might need to consider next year, maybe I only put on 180 pounds as gas up front, and I use some fertigation in season. And in the high prices, I got a lot of folks to pull. And remember, they're doing 300 pre-nitrogen. They were doing 270 pre-nitrogen in an environment that doesn't leach. This is the high plains. Evaporation beats irrigation rates easily. And we were able, when nitrogen went up, they were much more apt to listen to pull back on that pre-plant rate to the 240, 220 pre-plant. And it made just a little visual. I do have one question. I'm about out of time, but I got one question. Because you mentioned with the MRNT that you kick out the old data. What have you seen over the years of MRNT about? Has there been any shift other than yield? I mean, what's the shift that's occurred in that over the years of MRNT?
Maximum return to nitrogen, it's a phrase that we used and we didn't expect it to take hold, but I think it sums up the approach pretty well. It's a economic decider. The answer to your question and what's changed, I think it's a lot of it's related to hybrids. A lot of it just comes from breeding for high yield. And so we have the data would show that MRTN value has risen fairly steadily over the last 20 years now. But we never set out systematically that happen. So we always have to be really careful and say, well, did that really? To me, it makes sense mostly because I think the crop is so much better at taking up the nitrogen that's in the soil. Root integrity, I talk about the connections in the soil. I think it's important when we get some dry weather that water and that nitrogen that was moved below the rooting zone by early rains can actually come back for the crop. And it does. And we've seen years. We have a lot of people that are still, in a panic when it rains 3 inches in mid-April after they put anhydrous on earlier or put it on last fall. And we're still putting some on in the fall. At some point, I think we'll probably ease away from that maybe over time. We just know from our research that, you can get yields from it if farmers are using a little too much nitrogen. Anyway, fall works fine, but we lose more of it. And we lose probably 15, 20 pounds more nitrogen from a fall application than from spring. So is that enough to change people's minds? I like anhydrous as a source, especially a spring source. It stays where it's put better than anything else. And it's in the soil, and the roots don't have to go looking for it everywhere. But I think that's the biggest difference. The yield levels have played some part, and honestly, if you get high yields, you need a lot of nitrogen. It's just a question of how much of it we have to put on with the applicator, how much is going to be there. So I think we're working slowly at it. I think we have some people now that have seen. We have one farmer that did about 12 years in a row. He did a nitrogen trial for us, and at the end of it, I don't think he ever got above needing 175 pounds in any given year, and this is 245 yield levels. So it takes time to get there. Nobody wants to really get out and regulate and say, oh, you can't use that nitrogen on that field. And no, it's nobody wants to regulate. I hope that we can be rational about it. Some people say, well, economics shouldn't, it doesn't include the environment. environmental effects of having a bunch left over, and we can start to include that. We have the data. We know that once you get past the optimum for a field, you are going to probably leave more behind, and it's going to go out the tile line. A lot of it will, and under our conditions. Uh, so I really wish, I really kind of envy you for the irrigated corn because everything's under control with irrigation. When it's not irrigated, it's not really. And so we worry about a lot of these things. But, with a soil that's providing nitrogen, and I think nitrogen generally stays in the soil more than people's imagination tells them that it does. And so I think we could relax a little bit more about nitrogen. For most people, they're putting on enough that they're not losing any yield from not having enough nitrogen. And we have, as humans, Brian, we like to take credit for the things that we do. And I said the nitrogen rate is one thing that we do, and we go take the applicator and put it on. So if we get good yields, it was due to our
It's due to us.
Yeah.
Well, Dr. Nafziger, we've hit the end of time. In fact, gone a little bit over. Thank you so much. Talking about a topic that, for me in my career, I found has a lot of emotions tied to it when producers are making decisions. So, folks, with that wraps up another episode of the Crop Science Podcast Show presented by Wyzenetics. Thanks for joining us today with our guest, Dr. Emerson Nafziger, Professor Emeritus of Crop Sciences, University of Illinois at Urbana-Champaign. Remember, guys, if you have enjoyed this podcast, hit that subscribe button so that you get notifications every time we drop a new podcast. Also, leave us a comment or any suggestions you may have for new guests. Dr. Nafziger, thank you so much for taking the time with me today. Always enjoy visiting and learning from you. Thank you.
Glad to be here.